asked the question, when I asked you the question, please switch on your audio. Okay? Yes, Ravi. Can you tell me what is the significance of Friis equation? The session has to be interactive, है ना? So it should not be one-way session.
Sir, don't know.
Don't know. Last lecture में थे क्या तुम? Okay.
Yes, sir.
ठीक है. So see, Friis equation is nothing but it is a very basic or very fundamental equation when we are talking about the electromagnetic wave propagation. Okay. So what this Friis equations gives us, so this Friis equation give the relationship between the transmitted power and received power. Okay. Because in communication, the amount of received power is very important because on the basis of that received power, we are going to reconstruct the original transmitted signal. So this Friis equation gives the relationship between the transmitted power and received power. So we already discussed about this Friis equation in previous lecture. Okay. So here, when we are going to study the Friis equation, we should know the what is the free space. So we know we already discussed about the free space. We should know the isotropic source. So isotropic source is nothing but it is a source who radiates the equal amount of energy in all the direction. So we already seen this one. Power density. Power density is nothing but it is a power. Uh, it is the radiated power per unit area. So we already discussed about all these things. We know the formulas also. So this is the transmission of electromagnetic waves. In X direction, we have the electrical energy. In Y direction, we have the magnetic energy. And this Z direction show the propagation of wave. And this is the equation which is used to calculate the amount of received power. That is, PR is nothing but it is a power integration of power density is with reference to the surface area, right? So from this we already calculated the uh, that is the total amount of received power. Okay, and this A is AE. AE is nothing but it is the effective area. Effective area which is concerned with the receiver antenna. Okay, and A is calculated by using the formula that is A is equal to lambda square divided by 4 pi g, and here lambda is a wavelength. So further we derive the equation that is received power is equal to transmitted power into gain of transmitter antenna, gain of receiver antenna, wavelength square divided by 4 pi r square. So in some books, the distance between this transmitting antenna and receiving antenna is denoted by the suffix d, and in some books it is denoted by the r. So don't make confusion. Okay, what is r and what is d? Okay, so it is related with the distance, right? Distance between the transmitting antenna and receiving antenna. So again, we already discussed about the path loss. Path loss is nothing but it is a ratio of transmitted power versus received power. Okay. Uh, Now this is the summary we already seen in previous lecture. So this is the formula to calculate the amount of received power. This is the formula to calculate the amount, calculate the power density. This is the formula to calculate the antenna effective area, right? And finally, we have the that is the path loss equation. So path loss equation is nothing but it is just now I told you it is the ratio of transmitted power versus received power. So it is calculated with the help of this formula. We already discussed all these things in previous lecture, and we also seen one problem. In this, we have a transmitter antenna. We have a broadcasting station who transmit the some amount of power. Okay, and the receiver antenna receive the some amount of power, but there is a loss between the there is the difference between the transmitted power and received power. So some loss is there. So here in this example we already discussed, that is the this received power is given, received power is given, and frequency is also given, gain is also given. So from this we are going to calculate the transmitted power. So we already solved this problem, and we know how to calculate the total amount of transmitted power. Okay. Now this thing is over in a previous lecture. So in previous lecture, at the end of previous lecture, just we started the we started the to understand the difference between the antenna and transmission line. So we already discussed about the transmission lines. So transmission lines are nothing but transmission lines are used to transmit the electrical energy from one place to another place with the help of some conductors. So why there is necessity to understand the difference between transmission line and antenna? Because if somebody says that, sir, can we use the transmission line as a medium to transmit the energy from transmitter to receiver? Okay, so here if such question arise, so to answer such type of question we should know what is the difference between the transmission line and antenna. So in previous lecture we discussed about this key. Transmission line is nothing but it is a conducting material who carries the energy from one place to the another place. Okay, and antenna is nothing but antenna do same thing. It also carry the energy from one place to another place. Okay, then what is the difference? So the main difference is that key antenna transmit the energy from one place to another place, but antenna is act like a transducer. So transducer is nothing but it is a what we can say, it is a mechanism who convert one form of energy into another form. So in antenna, what happens? We are going to convert the electrical energy into the electromagnetic wave. Okay, or at transmitter station and at receiver station, we are doing exactly reverse thing. At receiver station, what we are doing? We are converting the electromagnetic wave into electrical signal, and we will regenerate the data at receiving station. Okay, this is the one major difference. Now the second difference is that key in transmission lines, so whatever energy we are transmitted, so that energy is remain within a circuit. Okay, within a circuit means this is very significant point. You have to understood this. Means when we are talking about the any circuit, so the circuit has to be closed loop. So if circuit has to be closed loop, then only energy will be transmitted or the electrons will be moved from one place to the another place. Okay. If the circuit is open circuit, then we cannot transmit the energy. So in transmission line, we have a closed loop. But in antenna, uh, in antenna, we doesn't have closed loop. In antenna, the the what we can say, the end part is open. End part of the conductor is open, through which we can generate the electromagnetic waves. So in next slide we will see how this electromagnetic wave is generated with the help of open wires. Okay, so that is the basic difference. Means if we want to differentiate between the transmission line and antenna, the first difference is that the transmission line is act like a conductor and antenna is act like a transducer. First, the second point is that in transmission line, whatever transmitted energy which is in electrical form, it will remain in the form of energy will remain same. Okay, we are not going to convert the electrical energy into some another form. But in antenna, we are going to convert the electrical energy into the electromagnetic wave. and vice versa. Okay, that is the second difference. Okay, and third thing is that in transmission line, whatever energy we are transmitted, so that energy is remain, and that energy is remain within a system. Okay, means here last point you can observe here, in transmission lines, the energy is remain within a system. Okay, or energy is remain within a system. Okay, but in antenna, so energy is thrown in atmosphere, so that energy is not remain in the system. Okay, that is the another difference between the transmission line and antenna. Okay, so we are not at all much more interested in transmission lines, but for the clear cut understanding of antenna, we should know the difference between the transmission line and antenna. Okay, so now further onwards we are only focusing on the antenna. We are not talking about, we will not talk about the transmission line, right? So now we will discuss about the antenna. Okay, so antenna means what? So first we have to understood the definition of an antenna. Okay, and this antenna is invented in 1857. Okay, by the scientist Hertz. So on behalf of his name, we are having the unit of frequency as a hertz. Okay, so what experiment he does? He did. So what experiment he did? So he has taken two conductors. Okay, he has taken the two wires, and when he will pass the energy through these two wires, means for understanding, suppose this is one wire. Okay, so in diagram you can observe this, but just I am going to draw the diagram. Here we have the two wires. Okay, so this is in these two wires. Here what I did, here I applied some amount of energy. Okay, here I applied some amount of energy. Okay, energy or some voltage source is there, and here what happens is, suppose this is the positive positive and this is the negative. Okay, so when, and these two wires are open wires. So what he observed, these two wires are open wires, but still he will observe some spark here. He will observe some spark between these two wires. Okay, so from this what he conclude, he definitely there has to be some amount of energy. There has to be, suppose this is the A point and this is the B point. So here there is some amount of energy is transferred from this point to this point, or this point to this point, vice versa. Okay, so he observed these things. Means he conclude that if loop is not at all completed, still there is a transmission of energy. Okay, so this is the basic finding of Hertz. Antennas are working on this principle. Okay, so how it will work, we will see in detail. But right now you have to only understood that the antenna, the experiment related to the antenna is firstly done by the scientist Hertz in 1957. Okay, so what he observed an electrical spark in the gap of dipole antenna. Right, he will observe the spark between these two dipole A and B. When using a loop antenna as a receiver, he observed the similar disturbance. Okay, so how it will work, we will see in next slide. So further, we have to first understood the definition of antenna. What is an antenna? Okay, so there are different definitions. Okay, but the meaning is abstract is same. So the American Heritage uh, Dictionary, what it states, antenna is nothing but it is a metallic aperture for sending and receiving electromagnetic waves. Aperture means it's like a hole, right? So it is a metallic aperture for sending and receiving the electromagnetic waves. Okay. Now here we have the another Webster's dictionary. So what it states, okay, antenna is nothing but it is a usually metallic device as a rod or wire for radiating or receiving the radio waves. Meaning is same. Okay, in both the cases, if you will see the summary or abstract, meaning is same. Now we have the this another book. What it state, that is the antenna theory book. So what it state, an antenna is a transitional structure between the free space and guided structure. Okay, guided structure and free space. So here two terms are there. Means meaning is same, but here uh, the definition is much more technical. So we have to understand this. Here free space. So free space means what? Is suppose we have this is our transmitter antenna. Okay, this is our transmitter antenna, and this is our receiving antenna. So in receiver antenna, here before this means suppose here some microphone is there, some amplifiers are there. So here these microphone, amplifiers, and antenna. So whatever devices are there, they are connected with the help of some wires. Okay. So wires means when the signal is transmitted through wires, so then we will call it as a it is a guided transmission, or in other words we can say it is nothing but it is a guided structure. Okay, and here once the signal is come to the come through all these devices to antenna. So what this antenna does, this antenna will transmit this signal in the form of electromagnetic waves. It means from here, from this transmitter to receiver, it will transmit the signal in the form of electromagnetic wave. So here we means between transmitter and receiver we have this free space. Okay, so means antenna is here what this definition tells us, an antenna is a transitional transitional structure between free space and guided structure. So this one is nothing but we called it as a this is the guided structure, and the distance between the space between this transmitter and receiver antenna is nothing but we called it as a free space. So I think definition is clear. So antenna means we have the three different definitions. One is the antenna is a metallic aperture for sending and receiving electromagnetic waves. This is the first. Second one is it is a antenna is a metallic device, or it may be rod or wire for radiating or receiving the radio waves. This is second definition. And third one is an antenna is a transitional structure between the free space and guided structure, right? So I think you got the definition of antenna, right? So now further we will see what is the uh, different function, or what is the how this antenna works. Okay, so normally the antenna performance is depend upon, first you have to remember this, first it has to it will be depend upon the channel characteristics. Okay, so what are the different channel characteristics? We will see all these characteristics in detail, but right now you have to remember only that key antenna performance is depend upon the channel characteristics. Now second is antenna performance is depend upon the signal frequency, and third one, that is the antenna dimension. Okay, so these three parameters will be decide the performance of antenna. Means right now you have to only remember these three things. Okay, we will study all these three things in detail in next chapter, so don't worry about that. So right now simply you have to understand that the antenna performance is depend upon these three parameters, that is the channel characteristics, signal frequency, and antenna dimension, right? Now here the antenna, we already discussed about the definition of antenna. Okay, so antenna means here antenna is nothing but it is a metallic device for radiating or receiving the power. Okay, so now when we are talking about, when we divide this antenna into different categories. Okay, so these antennas are divided into the two categories. Okay, first one, that is a transmitting antenna. Okay, so this is the first type we can say, or category, whatever you can say. The first one, that is the transmitting or transmit antenna. Okay, transmitter antenna, transmitting antenna, transmit antenna. Okay, the second one, that is a receive antenna. So this is the second type. Okay, so means whatever antennas means, there are n number of types of antennas are there. So we will see one by one, but all those antennas are divided into these two main categories. So those antenna will come under either transmit antenna, or they may be come under receive antenna. Okay, so here, what is this transmit and receive antenna? Theoretically, both are same. Okay, both the functioning of both the antennas are same, except only in transmit antenna we are converting the electrical energy into electromagnetic waves, and in receiving antenna or in receive antenna we are going to convert the electromagnetic wave into electrical energy, right? So this is the only difference between transmitting and receiving antenna. Otherwise, the construction wise, or this channel characters wise, or whatever frequency or antenna dimension, everything, whatever parameters are there, so all those parameters are applicable for the transmit antenna as well as receive antenna. The only difference is that they convert the which type of energy into which type. So that is the only difference. In transmit antenna, we are going to convert the electrical energy into the electromagnetic waves, and in receive antenna or receiving antenna, receiver antenna, we are going to convert the electromagnetic wave into electrical energy. Okay, now I think the transmitter antenna and receiver antenna is clear to you. One more difference is there, a small difference. The practical implementation issue means uh, actually on what we can say, practically when we implement or when we deploy this transmitting antenna, transmitter antenna and receiver antenna, so there is again one observation is there. Ski transmit antenna handles the high power. Okay, high power means whatever the amount of transmitted power. So, but obvious it has to be greater than the receive power. Why? Because when the electromagnetic wave travel through the medium, then there are some losses. Okay, so losses are because of the reflection, refraction, atmospheric losses, thermal losses, some noise is there. Okay, so because of those issues, the transmitted power will be lost. Okay, so here when we compare the transmitted power or or the power from transmitter antenna is is higher as compared to the receiving antenna. Means in simple language, how we can analyze this? Key transmitter antenna radiates the power in watt or milliwatt. Okay, and when we receive the same thing at receiver, then the receiver antenna is having the power in milliwatt or microwatt. Okay, so this is the another difference. It means in transmitter antenna we have high power and high power as compared to the receiving antenna. Okay, now this is the another thing which are related to the antenna. Okay, so this is nothing but different types of antennas are there. So what uh, a structure designed for radiate and receive the electromagnetic energy in a prescribed manner. Okay, so this is the definition of antenna. The the importance of the shape and size of the structure. So we have the different types of antenna: dipole, loop, slot. So next slide we will discuss about this. Means you have to understood that key the efficiency of antenna or quality of antenna is depend upon the radiated power and the received power. Okay, So that we will see in next slide. Okay. Now here, this is the simple of the basic structure of antenna. Okay. So this antenna is also called as a dipole antenna. So what is a dipole antenna? Here you can observe this is the actual image and this is the diagram. Okay. So in this dipole antenna, we have the two wires. These are the two wires, right? This is the first one and this is the second one. Okay. And here at this level, okay, at the beginning of antenna, we are applying the some energy source. Okay. Here we are applying the some energy source. So here, when we feed the power to this antenna, and you can observe that if this end is open, you can observe that this end is open and this end is also open. Okay. And here means this antenna at this part only, this electrical energy is converted into electromagnetic waves. Here electromagnetic wave will be generated. How it will generate, uh, we will see. Okay. Means, but this is the basic structure from where we have the, means we have a source who feeds the energy to this antenna, and the end of this both the wires are open. Okay. They are not interconnected. Okay. And from this, the at this point the electromagnetic wave will be generated. Okay. Now this is the actual diagram. Here we have, you have the wires. One wire is going towards this, one wire is going towards this. Okay. How it will generate, let us see. This portion is also called as a pole. Okay. This dipole means we have the di is two, we have the two pole. So this antenna is called as a dipole antenna, right? So just now I told you ki how the structure will be designed. So here this is Vs is nothing but this is the source. Okay. So this is the source where we can feed the energy. The form of energy is electrical energy. Okay. And through this we have the some impedance matching network, and through this energy is transmitted to the this energy will be transmitted into the uh, atmosphere or space by using these two dipoles. Okay. So with the help of these two dipoles, we can transmit the energy. So this is the only, this is, nothing is complicated. This is a simple basic structure of antenna. Yes, we have a source, we have some transmission mechanism, and at the end we have some poles through which we will transmit the energy. Okay. And here there is a one important parameter, that is the impedance matching. Okay. So we will see impedance matching in detail. Okay. So in next chapter. So now this is a simple, is a this is the only block diagram, and if we further, if you will analyze this all this mechanism in the form of electrical circuit. So here this is a your source, this is the intermediate part is a transmission line. Okay. Transmission lines means it will form, it will transmit the same type of energy. Okay. Electrical to electrical. Okay. And here we have the antenna. So what this antenna does, this antenna will convert this electrical energy into electromagnetic waves. And okay. So this is the simple equation to calculate the impedance. Okay. So we will discuss all these things. uh, so what are the different functions of antenna? Next part means up till now we studied the what is antenna. Now the second part, what are the different functions of antenna? Okay. So the first important function is that the antenna is used to radiate the electromagnetic wave. Okay. That is the first function. The second function, in receiving mode, it receives the electromagnetic waves and convert into the electrical signal. Okay. And just now I told you, okay, this antenna is nothing but it will act like a transducer, which convert the electrical energy into the electromagnetic wave energy. Okay. And this will happen electrical to electromagnetic at transmitter and exactly reverse at the receiver. Okay. So these are the main functions of antenna. Yes, it will convert the electrical energy into electromagnetic wave at transmitter, and it will convert the electromagnetic wave into the electrical energy. receiver. Okay, so this is the uh, or these are the functions of antenna. Okay, now radiation mechanism. So radiation mechanism means what? How the energy is radiated. How the energy is radiated means, if you will see this one, if you will see this antenna. Okay, so in this diagram, so here this is the source, this source, right? This is the transmission line, right? And this portion, these two poles, so these poles are nothing but we called it as a radiation mechanism. इसको हम लोग क्या बोलेंगे? We called it as a radiation mechanism. Okay, and how this radiation mechanism works, so that we will see in next lecture, because we have only one एक ही minute बचा हुआ है. So that we will see in next lecture. Okay, so what is the radiation mechanism? Okay, so in detail we will see in next lecture. So I think in today's lecture, just if I want to summarize, so today what we will what we were discuss, key what is the difference between the antenna and transmission lines. So that is the first point. Second point, invention of antenna. Key, what experiment is done by Hertz. Okay, so that we already discussed about this one. So antenna is invented in 1857. Okay, so now after that we seen already we have the different definition of antenna. Just already I told you the meaning is same. The different organization or different bodies given the different definitions of antenna. So one is a metallic, this one. The antenna is nothing but it is a metallic aperture for sending and receiving electromagnetic waves, or it is a device to radiate or receive the energy, or it is a transitional structure between the free space and guided structure. Okay. And now after that, main major types, that is transmitter antenna and receiver antenna. So here transmitter antenna is having high power as compared to the receiver antenna. Okay. Now, yes, different types of antenna. So that again we will see in detail. This is the basic core structure of antenna. It is having the source, transmission lines, and dipole. Okay. Uh, and if we want to convert this block diagram into the some electrical circuit, so this circuit will show you the source, transmission lines, and antenna. Okay, and different functions of antenna means antenna radiates energy, it will receive the energy, it will convert the one form of energy into the another form. So in next lecture we will see the radiation mechanism. Okay, so are you getting the things? Yes, can anybody tell me? Yes, निखिल भक्ति आप बता सकते हो? Are you getting my voice?
Yes, sir.
आ रहा है समझ में?
हाँ.
Okay, so radiation mechanism हम next lecture में देखेंगे. Okay, we have only few seconds. So shall we stop here?